Hello everyone to the second video of the NumPy tutorials for beginners series. In this video we will be covering indexing, slicing and Boolean indexing. So first, what is indexing? Indexing is used for obtaining a single value from a NumPy array. For example, we'll make a NumPy array starting from, let's start from 4, and we start from 4 and then we go up to 10 but not including 10 itself. And this is very similar to indexing Python lists. So let me print out A as well. So the array A is 4, 5, 6, 7, 8, 9, and then we print out the first element. So the first element is 4, and then we print out the second element, which is 5. So NumPy arrays are the index starts from 0 and the index goes up. You can also use negative indexing. So -1 refers to the last element, so 9, so that's why 9 is printed out. Now let's talk about indexing multidimensional NumPy arrays. So when indexing Python lists, you usually have to use two indexes. So let me change this to 1. So what happens here is that the first index refers to the second row, which is 3, 4. And then this 0 index refers to the first element within that sublist, so we should get 3. So yeah, so we get a 3 output. So when you are indexing a NumPy array, you can still use this index, but it's better to actually uh, have only one index operator and have two arguments separated with a comma. So if we run the code here, we still get a3. So that's how indexing works. So it's a good idea to use the comma within your index operator. So now let's talk about slicing. So slicing is used for getting certain rows and certain columns. So it looks very similar to the index operator. And let me also print out A over here. So you can see that I get the first output is obviously A, and to get the first row, what I do is that I have a 0. So 0 refers to the first row, so 1, 2, 3, and now I have a column over here, and this column refers to all the columns. To get this first column, what I do is I refer to all the rows, so all the rows basically is the whole array, and this 0 index refers to only the first column. So the first column is only 1 and 4, so 1 and 4, and that's why we get the output 1, 4. Finally, let's see the last index. So this is the second row, right? Because 1 refers to the second row. So the second row has 4, 5, 6, and I want columns 1, 2, 3. Now 1 actually refers to the second element, which is 5, and it goes up to 3, index 3, but it doesn't include 3 itself, so it only looks at index 1 and 2. So index 1 and 2 is element 5 and element 6, so that's why we get output 5, 6. So that is slicing. So now let's talk about Boolean indexing. So Boolean indexing, so the great thing about NumPy is that you can use the conditional operator on multidimensional arrays. So this is our multidimensional array 1, 2, 3, 4, 5, 6, 7, 8, 9, and then what we do is, let me print out the Boolean index. So here what we have is we have array A, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and we also get a Boolean index array that has the same shape as the original array, except that the elements have been replaced by true or false. So it is false when the elements don't satisfy the condition here. So the condition here is it has to be greater than 5, but 1 is not greater than 5, so it's replaced with false. So 1, 2, 3, 4, 5 are all false because they don't satisfy the condition. 6, 7, 8, 9, they satisfy the condition, so that's why they have true. So to do Boolean indexing, all you need to do is put in the array followed by the conditional operator. And in NumPy, the conditional operator is kind of element wise. So instead of the whole array being greater than 5, which doesn't mean anything, it looks at each element. So each element is a number, so you can obviously compare it with the number 5. So now let me uncomment this. So what happens if we put in the Boolean index into the index operator? So let's run the code, and you can see that I get a one-dimensional list that contains the elements that satisfy the condition. So yeah, and in fact I can replace this with a is greater than 5. So yeah, this also works just fine. So this is a slightly more concise syntax. So yeah, you get all the elements that are greater than 5. They have to be strictly greater than 5. So now let's talk about the NumPy where function. And let me also print out b. So what we have here is we have the array A. So array A is 1, 2, 3, 4, 5, 6, 7, 8, 9. And what B does is you have to first input a condition followed by the array and followed by a number. So any element that does not satisfy the condition is replaced with -1. So you can see here that there's a -1 for elements 1, 2, 3, 4, 5 because they don't satisfy the condition. But the elements that do satisfy the condition, they are replaced with -1. So that's why you have 6, 7, 8, 9. They're left unchanged. So yeah, that's how the np.where function works. Now let's talk about fancy indexing. So in Boolean indexing, we have a condition that returns true or false. But in fancy indexing, we allow indexing with integer indexes. So here we first print out array A. So we have this the array generated, and then we index the elements at index position 1, 3, and 5. So the second element is 1, the fourth element is 3, and the sixth element is 5. So that's why we get this output. Let me use a better example. So I'll use 7. The array will start at 7 and will go up to 20. So not including 20 itself, so it stops at 19. So index positions 3, 5, 1, 3, and 5 refer to the second, fourth, and sixth element positions. So we have 8, 10, and 12. So that's our output. So that's fancy indexing. Now let's talk about the argwhere function. So the argwhere function returns us the indexes of elements that satisfy the condition inside the function. So let me write in the code. I have to also print out the index positions. And let me also print out A. So A is 1, 2, 3, 4, 5, 6 in a 2D format. And what happens is that we have an argwhere function where I have to write in the array and a Boolean condition. So I the output what I get is an array which contains the index positions. So a is greater than 2, so the first element that satisfies the condition is 3. So since 3 satisfies the condition, the index position of 3 is 0, 2. So this is 0, 2. Next is element 4, which also satisfies the condition. So we have 1, 0, then 5 and 6 also satisfy the condition. So these are the index positions for those elements. So if you have an array and you have a condition and you want to find the positions of the elements that satisfy the condition, you can use the argware function. So that's about it for this video, and I'll see you in the next video. And if you like this video, please consider liking and subscribing to this channel.